All right, this is what is a limit part 2. So we're going to look at the graph and evaluate the limit if it exists. This says the limit as x approaches 4 of x plus 3. So first of all, that's how you read that, the limit as x approaches 4. What does that mean? Well, to approach 4, as for x to approach 4, it approaches 4 along the x-axis. So be coming along the x-axis, approaching 4 from the left, but we can also approach 4 from the right. So along the x-axis, we're approaching 4. So then of x plus 3. So this line represents the equation y equals x plus 3. So it wants to know what is our line in this case doing as x approaches 4. So as x approaches 4 from the left, our curve is approaching this value right here, 7. And as x approaches 4 from the right, our curve is also approaching this value, 7, which should mean that the limit as x approaches 4 of x plus 3 should be 7. So that's how we do it in a graphical sense. You can see too that in terms of what we learned last week, it's safe to allow x to approach 4 because the denominator is a 1 in this case and will not be approaching 0. So we could simply let x approach 4 and we would get 4 plus 3 or 7, and that would be algebraically by substitution. So the graphical analysis agrees with just being able to substitute in here. So the next example we're going to look at is another graph here. You can see this smooth curve here. Look at the graph and determine the limit if it exists. This time we're looking at the limit as x approaches 5 of this curve here. So again, we're going to let x approach 5. So here's 5. X can approach 5 from the left as well as from the right. And our curve is approaching a value from the left as x approaches 5 and from the right as x approaches 5. And it's that same value, this value right here, which appears to be 1. So we're going to say we think it's 1 from our graphical analysis. But also, again, is it safe to let x approach 5? If we did, the denominator would approach 15, so it is safe. So we could say the limit as x approaches 5 of this rational expression could be 5 squared minus 3 times 5 plus 5 over 2 times 5 plus 5. So we have 25 minus 15 plus 5 over 15, which would be 15 over 15, also 1. So again, our algebraic analysis agrees with our graphical analysis. And that is the end of part 2. Press this.